Okay, now we're going to refer back to our drawing. This is the gyro frame, and we want to establish a 0, 0 coordinate or home position here in the bottom left corner of our gyro frame. We'll be putting a series of 1/4 inch and 3/8 inch holes, and we can, once we've established the 0, 0, we can just put the center of those at each of these increments out there. So 0, 0 on our part, this bottom left corner here, I've marked it with a little bit of Dicom blue there so we remember and reference that. We're going to use our edge finder to find this back edge here, and remember our part will be 0.1 this side of that. And what we'll do is, since our part is clamped in the vise, we'll actually pull off the back edge of this vise right here because we know that 0 of this is the same as the 0 of our part. So when we pick up the back edge of the vise here, we've got to remember that we've picked up 0.1 to the inside of our part. So in this case, we'll add 0.1, or as I said, the radius of our edge finder to the reading that we get, and then we can establish 0, 0. So let's go ahead and do that. Okay, we'll bring our edge finder in just until we touch, smooth, and we kick over. And we're going to come up to our display. We will 0 our x. We're going to add that 0.1 back to our x-axis so we can set this right at 0. So there's 0.1 and 0. So our x is now 0'd. Okay, now as I mentioned, to 0 our y, we're going to pick up the back edge of the jaws of the vise here. Same technique. Smooth. And kick over. Okay. Now we'll 0 our y. We'll move this over. We'll go ahead and add back in that 0.1. Close enough. And 0 our y. Okay, now we're going to switch out our edge finder and put in a drill chuck. Alright, there's our drill chuck. Standard looking drill. Go up in our 1/2 inch collet. Okay, now we're going to have to lower our table. Our spindle's all the way up. We're going to have to lower our table in order to fit our drill bit in there. Alright, let's place our 1/4 inch drill bit there like a normal chuck. Use the chuck key. Tighten that up. Good to go. A drill chuck is not as accurate as a collet because we introduce both a small amount of error when the drill chuck is inserted into the collet and a small amount of error in the chuck itself. For the precision that we need for the location of the holes, this will be fine. Alright, once again, referring to our drawing, the location of our first hole will be up 1 1/8 inch from the bottom edge and over 3/8 of an inch from the left edge. X, we're looking for 0.375. Shot over that one. Always approach it from one side. 375. Right on. And our Y, we're looking for 1.125. This number is negative because we're moving up from the bottom. Oops. 1.1. You may have noticed me going back and forth and trying to hit that number right on. There's always a little bit of slack on these knobs both ways. The gears that move them across have a little bit of play in them. So you want to make sure that you're always approaching the measurement that you're taking in a continuous direction, if you will. If you approach it and kind of go back and forth, there's a little bit of play in there, and when the drill bit starts turning, that can take up that play and you'll get some movement in the machine. Okay, now that we are at 3/8 of an inch off the side and an inch and an eighth off the bottom, I will kind of confirm. Looks like about where we should be on our part, and we'll go ahead and start drilling that first hole. Okay, we'll go to the first hole. Take this in steps in order to break those chips off. Kind of peck at the hole as we go. If we keep going to those, make those chips really long, they'll start kind of whipping around and get in the way of some materials that can actually be hazardous or sharp. Okay, our next hole will be here at the same X coordinate system, so we don't need to change that. We're just going to move from 1.125 to 1.5, and then I'll actually just continue right on up to 1.875. When you turn off the machine, we'll drill a hole, we'll move out, we'll watch the coordinate system, move up to this one, drill the last hole, then we'll move back and over and get this hole over here. Alright, these chips, as I mentioned, can be razor sharp, so even when they're stopped, we want to use a brush or something to remove those chips off of there. So, right. Now we'll move over here and pick up this hole. We're going to pick up this series of holes across the top here, so we're going to be on this y-axis of your 2.625. Our first hole will be at 1.125, so we'll pick this one up, and then just like we did on these, they're all on the same axis. We'll go 1, 2, 3, hit those holes, and then move back and pick up this one. So 2.625 and 1.125 for that first hole. So our machine is sitting right there, so we're ready to go. Alright, we'll move over 0.50. And then 1.875. And our final hole will be here at 2.188 by 1.50. And again, we've dialed that in on our coordinate system there. The last digit, 10 thousandths of a place, not necessary. Okay, on to the 3/8 holes now. We're just going to change drill bits really quickly. 3/8 inch. Okay, now we'll go pick up a hole for the 3/8. Okay, looking back at our drawing here, our 3/8 holes are 1 1.25 inches over and 1/2 inch up from the bottom. So we're going to go ahead and locate those at 1/2 inch. We'll drill those 2 holes, and we'll come over here and then drill those 2 holes. Okay, even though the diameter of our drill bit has changed, the center location has not changed. So since we're going to be just putting holes, center-based holes, we don't need to compensate for any extra thickness of the drill bit. So like I say, we're looking for 1/2 inch up off of the Y and 1 1/4 inches on the X. So let's dial that in real quick. All right, looking for close enough. 3/8 holes. Our next value is 1.75. Pick up the other holes. Okay, for these last two holes, our drawing is calling for on the center of the X a 2.50 and a 1 1/4 and 1 3/4 locations. So we'll go ahead and knock those out. Okay, we'll dial in that X-axis right on. Perfect. All right, 1.75. There's all of our holes. And just like before, we can use this deburring tool to clean out these holes as well. Just like so, it'll take the little burrs on the backside of where these were drilled through off. And again, I like to do this partly so you don't cut yourself. We won't be clamping this flat in the vise, but it's generally a good idea. The next step to doing this will actually be countersinking those holes. There's a couple of different ways to do that. We could have put a countersink in and changed the bit after each hole that we drilled, brought a countersink down, tapped it out, and moved it back up. The amount of time involved in doing something where switching the bits back and forth every single time is kind of counterproductive and something that doesn't have a great tolerance or great need. So I'm going to show you another trick, sort of freehanding it in order to get those countersinks done on the holes. Okay, the technique we're going to use for countersinking these holes is to place the part on the back of the vise. And you can see the countersink bit here. It's about a 45-degree angle or so on that. See if I can rotate that around here for you. All right. And what's going to happen is this is going to come down into the part, and we're just going to break off that little edge in there. Now, if the part does grab, it's going to want to rotate, and it's going to rotate into the vise like this. So we've very specifically set the part a small distance off of here. I can make sure that I can get to each one of these holes. But if it does catch and grab, it's going to stop when it hits that vise. This way we can hold it with our hands and not have to worry too much about anything happening. This is the other reason why we've deburred the back of that, so we have a nice flat surface to sit on there. All right, so we'll go ahead and do that. So I'm sort of letting the bit bring the part into alignment with the hole. And it's not trying to grab it out of my hand or anything. It jumps around a little bit, but I'm not doing anything too special there. Alright, there we have it. I hope you can see in the video there, nice countersinking of each of those holes, both sides there. Alright. Now we're going to come back, we're going to mount this in the vise, and we're going to cut the slots. we're going to use a pair of D-blocks. We want to make sure everything is scrupulously clean. We're going to set these guys in here. Okay, and our parallel bars. Set those here. We're going to take our perfectly square piece. All line up here. Okay, we've mounted our part in a set of V-blocks supported with a couple of parallel bars. We're going to tap it down with a hammer so our bars are nice and stable, everything's nice and snug in there. The first slot we'll cut will be horizontally across this way. We could go ahead and do it this way, but we need to get those parallel bars underneath there, and we hit our parallel bar if we machined all the way through that. So we'll take this cut, we'll rotate our part 90 degrees, and then take another horizontal cut across that way. If our part was perfectly square to begin with, within a thousandth or so, and we use our work stop over here, we should be able to just pick the part up, rotate it, set it back in there, and cut the next groove. We may double check some of those measurements, but we should be able to do that. In order to identify where this location is directly across between these 2 points, we're going to use our edge finder. We're going to pick up on this edge. We're going to move over, not changing our X at all, and we'll pick up on this edge. The halfway distance between these 2 points, no matter what those 2 points are, as long as we don't change our X, halfway between that should be right on this line, and that'll get our bits centered over the middle of the part for us. So let's go ahead and get our edge finder, and we'll go ahead and do that. Okay, we'll pick this up with our edge finder, bring the quill down, and I've locked off my X-axis so that won't move for sure. I'm going to bring the part in, use our edge finder, and there. Okay, I'm zeroing the Y. Raise my quill. I'm going to jog forward a little bit here. I'm going to tap edge finder, make sure we got a good wobble on there. Bring this back down. I'm going to find it again from this side. Same story, once we zero out, right. There it is. Okay, what did that give us? 1.2056. We don't need to really compensate for the thickness of the edge finder because all we need is half of this. We need to find exactly half of that. So we've got about 0.6028 or so, I guess. All right, we're going to say about 0.6028 or so. Right there. Okay, so I've zeroed our y-axis. Now what we'll need to do is the same thing again, pick up on this side and this side, and then we can center our x-axis. So y is centered. We'll go ahead and move this guy this way, and some arbitrary distance for x this way. Bring our edge finder down, knock it off, start it up. This time I'm going to lock the table in the y direction. I'm going to bring in the X just until we see our little edge finder. Clip. Okay. Resetting my X axis. Raise my quill. Move to the other side of the part. And same thing. Right there. Okay. So what's our value on our x-axis? 2.9715. All right, we want to take half of that. I'm going to grab my calculator. All right, here's my calculator. Half of 2.9715, 1.48575. So we're going to go to 1.4858. All right, so 1.486 on our x-axis. And so for a visual confirmation of that, can see that our edge finder is lined up right over the corner of that guy. So makes sense, should be good. All right, so now we're just gonna go ahead and set that to 0. We set our Y to 0, and so we can pick up the very center of our part there. We'll go ahead and move over that, and then we'll machine this way, as I mentioned, rotate, and then machine again that direction. And once again, we're gonna switch to our 1/2 inch end mill. Okay, so our readout says 0, 0. And we look like we're pretty much in the center of our part. Okay, now that we've found the center of our part, we need to determine how long each of these slots are. So according to our layout, we have from the very center of each of those 1/2 inch wide slots, we're 1/2 inch off of the edge on either side. So if we come in 1/2 inch this way, and in 1/2 inch this way, in 1/2 inch on this side, in 1/2 inch this way, then we know that this is effectively a 2 inches by 2 inch. So what we need is the hypotenuse of a 45, 45, 90 degree triangle that has 2 inches on either side. Quick little bit of math tells us that that is, hold on, this length will be 2.828 inches. Okay, since our total length of the slot is 2.82 inches, and we're in the center, which is halfway, we're going to move over 1.414 inches, and then begin our cut and work this way. Okay, to begin our slot and to generally work in the Z axis, we're going to bring our quill down until we just touch the part. About there, and we're going to lock the quill, and then we're going to use the table to bring it up. We don't want to do more than maybe a 1/10 of an inch at a time on this cut, so it'll take us about 3 passes in order to make this cut complete. All right, so I'm going to bring the table up 0.1. There, then we're going to adjust the Z again and come back. That's it. Now what we'll do is a countersink or a chamfer edge on those by putting in a chamfer tool. And this time we're not going to move anything and we'll run along the same slot.